In this video, we'll talk about the types of solids that are formed by the different types of bonding. This can be filled in on the chart in your packet. The first type of solid is called an ionic compound. As the name would suggest, this contains ionic bonds as well. What you should need to know about ionic compounds or ionic bonding is that there is a transfer of electrons. And what that means is one atom is actually losing electrons while the other atom is gaining those electrons. The electrons are actually moving from one to another. And as discussed in previous chapters, we know that the metals lose electrons while the nonmetals will gain them. So the movement is from the metal to the nonmetal. An ionic formula, such as NaCl, is not an actual molecule. It's a ratio of ions. So there is no such thing as just one little piece of NaCl. What it is called a crystal structure that has a ratio of 1 sodium to 1 chlorine. This is what it looks like. This is an infinite structure, meaning it keeps repeating over and over and over again, but the overall ratio is always 1 sodium to 1 chlorine. That's what an ionic formula represents. Ionic compounds are solids that are brittle, meaning they don't bend very well, they mostly break. They have very high melting points and boiling points. They are non-conductive in the solid phase. However, if you dissolve them in water, you are able to free up the ions, and it will actually conduct in an aqueous phase in solution, or if you melt it into a liquid phase, the ions are then mobile. In the solid phase, they are not able to move, so it does not conduct. And most of these are soluble in water, although we will learn later on that some are not soluble. Covalent compounds involve bonding that is covalent. And in covalent bonding, there is a sharing of electrons. This is different than ionic, where there was a transferring, because in a covalent compound, neither atom either gains or loses. They actually both use or share the electrons between them. They're not being transferred either way. They're just being used by both. Covalent molecules such as CO2, sugar, C6H12O6, etc., are actual molecules. They are real things that exist. Like CO2 is a molecule that has 1 carbon and 2 oxygens. It is not a crystal structure like the ionic compounds were. Covalent solids are brittle, also breaking apart very easily, have a lower melting and boiling point, and lower could still mean a few hundred degrees, but definitely lower than ionic solids, are generally non-conductive in any phase, whether they're soluble or not, but most of them are not soluble anyway. Metallic solids are composed of things that have metallic bonding, which again are just metals. So if we're asking about the bonding within a metal like iron or copper, we have a metallic bond occurring. In a metallic bond, the metals are all losing electrons, which is what they do. However, there's no nonmetals to pick them up or transfer them to. So all the lost electrons kind of just hang around in this glue fashion, kind of in between all the metal ions. We call this a sea of mobile electrons, or sea of delocalized electrons, because the metals are all losing them, but nobody is gaining them. So they kind of just sit around, and all the metals can share them and use them if necessary. Metallic solids, while hard, are malleable. They're able to be bent and shaped, and that is due to the sea of mobile electrons around it. There are no stiff bonds that occur here. This is not a crystal. It's just a gluing together of ions. So this can be shaped and put out of order if needed. Metallic solids also have high melting and boiling points. They always conduct, whether solid, liquid, or any other phase. They are not soluble, though, so you will not get them into the aqueous phase, but they do conduct very well. And again, the reason is the delocalized electrons allow electricity to move through it, since electricity is just the movement of electrons. And the last type of solid to discuss is called a network solid. And this may seem weird because we've only had 3 types of bonding, so how could we have 4 types of solid? Well, this one also involves covalent bonding. The main difference, though, is that this is very strong covalent bonding, which allows them to have very high melting and boiling points, where normal covalent compounds do not have high melting or boiling. They have low melting and boiling points. These are still brittle, though. They do not conduct very well and are usually insoluble. And mostly you want to know just the examples. Things like sand, glass, or diamond, things like that. Graphite is another one. These are covalent compounds, however, they're very strongly bonded, so they fit into the category of network solids.